Comets are not supposed to grow tails that face the sun. That's basic astronomy. Solar wind pushes material away, not forward. Yet right now, two different interstellar objects, Comet R2 SWAN and 3IATLAS, are doing exactly what physics says they shouldn't. And what makes this even stranger? They're doing it at the same time, in the same general region of the sky, and from positions that, if you draw their trajectories out, place Earth right between their influence zones. Astronomers call it coincidence, others call it geometry, but to some observers, it looks more like a setup. Before we go any further, if you enjoy space anomalies, hidden science, and cosmic mysteries like this, smash that like button and subscribe, because the next few minutes go way beyond what the headlines are telling you. Now let's talk about what's really happening. It started when updated telescope imagery revealed that Comet R2 SWAN had developed a sunward tail, a rare and extremely abnormal formation where the comet's ion trail appears to stretch toward the sun instead of away from it. This isn't just uncommon. It's practically forbidden by standard comet physics. Normally, comets shed gas and dust as they heat up. Solar radiation blows that material backward, forming a tail trailing behind their orbit. It's predictable. It's boring. It's been observed for centuries. But R2 SWAN didn't behave like a normal comet. Its sunward tail emerged gradually, then strengthened. And when scientists compared its emission pattern, they noticed something uncomfortable. It looked eerily similar to what was seen in 3IATLAS. Not identical, but close enough to trigger questions. Because 3IATLAS isn't just another space object, it's an interstellar traveler, something that originated outside our solar system, which means its physics shouldn't necessarily look like R2 SWAN, a comet originally believed to come from our own cosmic backyard. Yet here they were, two objects with two very different origins, displaying disturbingly similar behavior. And that's when things got weird. Let's talk timing. When astronomers overlaid the updated positional data of R2 SWAN and 3IATLAS, something unexpected appeared. Their orbits didn't collide. They didn't intersect directly. Instead, their current placements form something like an arc around Earth. Not a perfect circle, not a symmetrical pattern, but a geometry that, by pure coincidence, frames our planet between two massive energetic bodies exhibiting rare behaviors at the same time. Scientists call it celestial alignment, but depending on how you look at it, you could also call it strategic positioning. Now don't misunderstand why nobody is saying these objects are aimed at Earth. That's not how orbital mechanics works, but the probability of two objects from two different points of origin developing rare sunward tail features while occupying flanking positions around Earth at the same time, that starts pushing out of coincidence territory and into anomaly. So what is a sunward tail actually telling us? There are a few possible explanations. One is that the comet is interacting with localized solar magnetic field distortions that behave differently in that region of space. In other words, space weather might be bending physics slightly. But here's the problem. None of the other nearby bodies show the same behavior. Not the regular comets, not the asteroids, not even the solar wind streamers, just R2 SWAN, and just 3IATLAS. Another explanation is that both of these objects are generating internal electrical activity strong enough to resist the natural solar flow. That's not normal. Comets aren't power sources. They're not supposed to emit organized electromagnetic fields, but spectral analysis of their ion tails reveals structured emission, patterned light intensity, almost like waves of energy moving along defined channels. Natural comets don't do that consistently, but both of them are. Here's where things start getting unsettling. Independent modeling by observational physicists simulated what would happen if two such objects were releasing ionized material and charged particles into surrounding space. When these models ran the data, they highlighted a possible interaction zone, and that zone aligned disturbingly close to Earth's magnetosphere, not inside it, but brushing its outer edges, almost like they're interacting with the environment around our planet. Some scientists argue that this could theoretically influence high-altitude ion layers, satellite readings, and even subtle fluctuations in space weather around Earth. not catastrophic, not end of the world, but significant. Especially when you consider that 3IATLAS is not from here, and R2 SWAN is suddenly behaving like something it's not. Now let's dig deeper into the comparison. 3IATLAS shows a pulsed outgassing pattern. Its brightness dims and spikes in measurable intervals. That alone is strange, because comets usually behave chaotically, not rhythmically. R2 SWAN, on the other hand, has recently shown microflashes along its sunward tail. These tiny bursts of ionized gas aren't random. They're spaced unevenly, but consistently, not static noise. Variable but structured output. Two different objects, two different timelines. Same type of irregular order, which pushes scientists to consider something uncomfortable. Maybe what we're observing isn't random behavior. Maybe these objects are responding to the same environmental factor, or worse, the same external signal. Now, no one's saying that signal is intelligent, but nature doesn't usually run synchronized experiments on our schedule either. NASA and other space agencies have been careful with their wording. They describe the phenomenon as space weather interaction effects, broad, safe, dismissible. But what's interesting is what they haven't said. They haven't claimed it's fully understood. They haven't stated it's resolved. And they definitely haven't rushed to present a complete explanation, which is usually what happens when institutions are still trying to figure out how much to tell the public. Because the truth is, when events in space start lining up like this, they don't announce conclusions. They monitor, they delay, they reroute observation satellites, they adjust telescope priorities, they collect more data quietly, and they only speak when uncertainty drops below a level they can control. There's another layer most people don't notice. When R2 SWAN developed its sunward tail, the brightness profile around its coma, the glowing cloud around its core, began to shift in an asymmetrical pattern, almost like one side of the comet was responding to something not coming from the sun. Now pair that with 3IATLAS, which shows internal luminosity fluctuations unrelated to solar distance. And suddenly you've got two bodies behaving like they're reacting to an invisible factor in interplanetary space. Some astrophysicists quietly refer to this as a local interstellar interaction zone. Not public language, not something you'll see on major headlines, but something discussed in fields where curiosity hasn't been fully replaced by caution. Now here's the part that gets overlooked. If two objects can influence the environment around Earth's space bubble without ever touching the planet, what happens when more of them pass through? Because statistically speaking, interstellar visitors are becoming less rare, not because the universe suddenly got busy, but because we've started looking properly. And what we're seeing means this might just be the beginning. 3IATLAS might not be special because it's alien. It might be special because it's early. R2 SWAN might not be strange because it's unstable. It might be responding to something new in its environment. And Earth just happens to be sitting between two cosmic anomalies while they unfold. This doesn't mean danger. Not yet. But it does mean the universe might be more interactive than we ever imagined. Less like a silent backdrop, more like an active system. And when two unrelated celestial bodies start behaving like coordinated participants instead of random debris, you don't brush that off. You pay attention. Because in space, patterns don't appear often, but when they do, they usually precede understanding or disruption or both.